So dear students, in the last lecture we have finished expansion of Fourier series of even and odd function. Okay, I hope you understood that topic. Now today we are going to start the new topic, expansion of Fourier series in the interval c to c plus 2l. So new topic is what? Fourier series. Fourier series in the interval c to c plus 2l. Okay, we will learn the Fourier series in the interval c to c plus 2l. Okay, so for this what I have to do? So we first let the function f of x can be expressed, or you can say be expressed. Let the function f of x be expressed in the Fourier series in the interval c to c plus 2l as follows. So we have the function f of x. We express this function in terms of Fourier series. So we have f of x equal to a naught plus sum running from n equal to 1 to infinity a n cos n pi x by l, and plus sum running from n equal to 1 to infinity bn sin n pi x by l. Okay, name this equation number what? Name this equation number star. Equation number star, where a naught, a n, and b n are Fourier coefficients. Fourier coefficients are to be determined. Okay, and we have the Fourier coefficient formula determined, where we have Fourier coefficient formula a naught. Your a naught is what? 1 upon 2l integration of limit c to c plus 2l f of x dx. Name this equation number 1. A n, your a n is what? 1 upon l integration of limit c to c plus 2l f of x and cos n pi x by l dx. Okay, name this equation number 2. And similarly we will have bn is 1 upon l integration of limit c to c plus 2l f of x sin n pi x by l dx, and this is equation number 3. Okay, so if you have the Fourier series in the interval c to c plus 2l, then we can express the given function in terms of this expression. Okay, f of x equal to what? A naught sum running from 1 to infinity a n cos n pi x by l, and plus sum running from 1 to infinity b n sin n pi x by l. Okay, so here again we will have the two cases. When c equal to 0, then your interval become what? 0 to 2l. And when c equal to minus l, then your interval become minus l to l. Okay, and the formula will also be changed over here. Okay, formula will also be changed accordingly. Okay, so you should remember this formula and the two main cases. If c equal to 0, then what will be your formula? If c equal to 0, then here what? Interval become 0 to 2l. Okay, so 1 upon 2l integration of limit 0 to 2l f of x dx. And here an will be 1 upon l integration of limit 0 to 2l f of x cos n pi x by l dx. And bn will be 1 upon l integration of limit 0 to 2l f of x sin n pi x by l dx. Okay, so in this way you can remember the formula. Okay, now let us start the problem, then you can understand how to apply this formula. Example, find the Fourier series of find the Fourier series of f of x where where f of x is defined like this, where f of x is defined by f of x is kx when 0 is less than x is less than 1 and 0 when 1 is less than x is less than 2. Okay, this function is given to you and we will find Fourier series of this function. Okay, so how to start? Let us start in the next page. Let solution, let f of x can be expressed as in Fourier series, that is a naught plus sum running from n equal to 1 to infinity a n cos n pi x by l and plus sum running from n equal to 1 to infinity bn sin n pi x by l. Name this equation number what? Star. Name this equation number star. Now what? Now we have to determine a naught, a n and b n. Now to find the Fourier coefficients a naught, a n and b n. So for this we have the formula a naught. A naught equal to what? What is the formula for a naught? 1 upon 2l integration of limit 0 to 2l f of x dx. Okay, f of x dx. But what? But by comparing this, you will get what? First limit is what? First limit is 0. Okay, and second limit is 2l. So by comparing this interval 0 to 2l, you will get l equal to what? 1. You will get l equal to 1. So but we have the interval what? 0 to 2l. Okay, so your interval is 0 to 2. Okay, by comparing this 0 is equal to 0 and 2l is equal to what? 2. So this implies that l equal to what? L equal to 1. Okay, so therefore a naught is equal to, we have a naught equal to what? 1 upon 2. 1 is l is 1 and your limit is 0 to 2. Your l is 1 and f of x dx. Okay, so this can retain as 1 upon 2. Now your function is divided into two parts. Your function is divided into two parts. First one is what? 0 to 1. 0 to 1 your first function is 0 to 1, limit is 0 to 1, and what is the function kx? So kx and dx, okay, and plus your second function running from 1 to 2, your second function running from 1 to 2, and for that we have the function 0. For that we have function 0 and dx, okay. Just integrate this. This is equal to what? 1 by 2 integration. K is constant, take outside, integration of x is what? X square by 2, and providing limit 0 to 1, and this will what? This will 0, okay. So this is equal to k by 2 is constant, I'm taking outside, so this is 1 by 2 into k by 2, and providing limit x square from limit 0 to 1. So this become k by 4, and here 1 square minus 0, so this become only k by 4, okay. So from this you got a naught is k by 4. Therefore you can say that a naught equal to uh, k by 4. Your a naught is k by 4. Name this one, okay. Similarly determine an. Similarly you can determine an. Let us move to the next page. So what is the formula for an? An is what? 1 upon L. Here your formula becomes 0 to 2L f of x cos n pi x by L dx, okay. So just write down.
सर सेकंड
So
पेज एक बार दिखाइए फिर से.
हाँ,
सेकंड पेज.
देख लीजिए.
ओके सर.
Okay, so we have an. Also we have an is what? 1 upon L, integration of limit 0 to 2L f of x cos n pi x by L dx. Just verify your formula. Here c will be what? C is 0. So this is an is 1 upon L, 0 to 2L f of x cos n pi x by L dx, okay. 1 upon L, 0 to 2L f of x cos n pi x by L dx, okay. This will this is your formula. But what? L is what? We found L is 1. We found L is what? L is 1. So instead of L we just put 1. So therefore an is equal to 1 upon 1 integration of limit 0 to 2 f of x and cos n pi x by 1 and dx. Just write down this in more simplified form. 0 to 2 f of x cos n pi x and dx, okay. Now just break your function. So we breaking your function. First one is limit running from, your limit running from the function have the your limit. First one is 0 to 1, then 1 to 2. So first one is 0 to 1. For that you have the function kx, okay, cos n pi x dx, okay, and plus second function running from 1 to 2, but function is what? Your 0, okay, cos n pi x and dx. Just close the bracket. Now this is what? Just integrate this. K is constant, I'm taking outside. Integration of limit 0 to 1, I'm taking k outside, so this is x cos n pi x dx, and plus this term will be what? 0, okay. Just integrate this. This is k. Apply generalized integration by parts. This is u, this is v. So x u integration of v, that is sine, the integration of v is what? Cos n pi x. So integration of cos is sine n pi x by their coefficient. What is the coefficient of this? N pi. coefficient of this is n pi, okay, minus derivative of this x is 1, and integration of sine is minus cos n pi x by their coefficient n pi is already here, so this is n square pi square, okay, and just provide limit 0 to 1, so this equal to k, just simplify, then apply the limit. So we write here x sine n pi x, okay, and by n pi minus minus goes plus cos n pi x upon n square pi square, okay, just provide limit. So this is equal to k, and upper limit, your limit is 0 to 1, upper limit is what, 1, so we write here 1 sine, instead of x we putting 1 sine n pi by n pi, and plus cos n pi, instead of x we have 1, okay, and divide by n square pi square. This is for your upper limit minus lower limit. What is lower limit? Yes, here instead of x we put in 0, so 0 multiply this thing will be what, 0, and plus we will have cos 0, okay, cos 0 divided by n square pi square, just close the bracket and simplify, this is k, okay, but sine n pi is what, sine n pi, sine multiple of pi is 0, so this will 0, and plus cos multiple of pi is minus 1, so this is general term, so this become minus 1 raised to n, and divide by n square pi square, okay, and minus and multiply inside, cos 0 is 1, so this is 1 upon n square pi square, okay, n square pi square. So this equal to k, okay, and just here denominator is same, the numerator will be added, k times of minus 1 raised to n minus 1 by what, n square pi square, okay. So this is your an, this is value of an, name this equation number 2, name this equation number 2. Now let us move to the next page. Let us move to the next page. Now what? Now we will find bn. Now we have bn. And what is the formula for bn? What is the formula for bn? Bn is what? Your bn is 1 upon L integration of limit 0 to 2L f of x sine n pi x by L dx. Okay. So just write down. So 1 upon L, your limit is what? 0 to 2L f of x sine n pi x by L and dx. But L, we found L is what? We found L is 1. Okay. So 1 upon 1 integration of limit 0 to 2 f of x sine n pi x by 1 and dx. You can mention the region since L equal to 1 we have. Okay. So just simplify, this is integration of limit 0 to 2 f of x into sine n pi x and dx. Okay, just break your function into two parts because we have two function. Okay, so first limit running from 0 to 1 and f of x, for limit 0 to 1 f of x is what, kx. Okay, and sine n pi x plus second limit running from 1 to 2, second limit running from 1 to 2, and for that limit function is 0, so 0 into sine n pi x and dx. Okay, so just integrate this. So here k is constant, take outside, integration of limit 0 to 1 x sine x sine n pi x, and this will what, 0 multiplied
इसका
by
वो
this will,
0 to 2 रहेगा ना लिमिट? अच्छा।
no, no, 0 to 1, then 1 to 2. Your limit will be continuous, huh? 0 to 1, then 1
हाँ
to 2, and 0 multiplied with this sine function will be what, 0.
हाँ सर।
Here you write dx, okay, and dx and plus this is 0. Now integrate this, k is constant, and apply, this is u, this is v, so u integration of sine is cos, that is minus cos n pi x divided by their coefficient. What is the coefficient? N pi, okay, and derivative of x minus derivative of x is what, 1, and integration of cos is sine, but minus sign is here, so we write here minus sine n pi x by divide by their coefficient n pi, but n pi is already multiply here, so this become n square pi square, okay. Just close the bracket and provide limit 0 to 1, and so before applying limit we must simplify the bracket first, then we will apply the limit. So this is k, and we write here into minus x cos n pi x by n pi, okay, and minus minus goes here, plus sine n pi x by n square and pi square, and providing limit 0 to 1, okay. Just apply the limit inside the bracket, so you have k. Now just provide the limit, upper limit and lower limit. So upper limit is 1, so we write it, this become minus 1, and cos, instead of x we putting 1, so this become what, cos n pi by n pi, okay, and plus sine, so this become sine n pi, okay, divide by n square pi square. This is for your upper limit, and minus lower limit here, instead of x we putting 0, so this become, whole thing will be 0, and sine 0 is also 0, okay. So this is 0 plus 0, just close the main bracket. So this is k, this is equal to k times of minus 1, okay, and cos n pi is what, minus 1, but here this is the general term, so we write minus 1 raised to n divided by n pi, okay, and plus sine n pi is what, 0, and everything is 0 over here, so this become k times of, see here, this can be written as what, minus 1 raised to 1, okay, and into minus 1 raised to n divided by n pi. So let us write this in the next page. So we'll have therefore bn is equal to k times of, say here base is same, the power will be added, so this become n plus 1, so this become what, minus 1 raised to n plus 1, and divide by n pi, divide by n pi, okay, and name this equation number 3, name this equation number 3. Now
सर
substitute,
पीछे वाला स्लाइड एक बार फिर से दिखाओ.
just observe this, you got it.
यस सर.
Now substituting all these values in equation number star, so just write down, putting equation 1, 2 and 3 in equation number what, in equation number star, okay, we get we get f of x, f of x equal to what, a naught. We first substitute a naught, what is the a naught, how much we found a naught, a naught is k by 4, your a naught is k by 4, and plus sum running from n equal to 1 to infinity, an, how much we found an, how much we found an, your an is k times of k times of minus 1 raised to n minus n. Just write down k times of minus 1 raised to n minus 1 by what? By n square pi square, by n square and pi square. And here we write here cos n pi x, okay, n pi x l, n pi x l, and plus sum running from n equal to 1 to infinity, and bn we found how much? Bn is this one, k times of minus 1 raised to n plus 1 divided by n pi and sine n pi x by l, okay. But l is what? We found l is 1, okay. Just here k is constant in each term, so we taking k common, we taking k as a common. Just take k common from each term, so we'll have k by 4 and plus what? K by 4. We take this common k by 4. uh, K is outside, I'm taking sum running from n equal to 1 to infinity minus 1 raised to n minus 1 divided by what? Divided by n square pi square cos n pi x, and plus k is outside, sum running from n equal to 1 to infinity minus 1 raised to n plus 1 sine, and divide by what? N pi also, and this is sine n pi x, and since here al is equal to 1, okay. Now just run the series, just run the series, okay. So this is what? K by 4 and plus k, run the series. So this is, pi is constant na? So pi is constant, I'm taking here outside, so this is pi square, this is what? Pi square, and we will remove pi square from here. uh, this is no problem, chalega. So this is what? Pi square, okay. Now just run the series. So you'll have for n equal to 1, for n equal to 1 you will get what? Minus 1 and minus 1, that is what? Minus 2, 2 by 1 square, okay. And cos, here instead of x we putting 1, so this become cos pi x, okay. And for n equal to 2, n equal to 2, so this is a square up, negative number is positive, this is plus, and this will minus, and this will 0, okay. So for even case this will 0. So here for odd case minus 2 by 3 square, okay, cos 3 pi x, okay, cos 3 pi x. Then next term will be what? Minus 2 times of minus 2 divided by 5 square cos 5 pi x, and minus so on, okay. This is for first term. And similarly you run the second term, similarly you run second term. This is what? K by pi, k by pi, I'm taking outside because the pi is constant, and run this series for n equal to 1. So this is what? For n equal to 1, this is 1 plus 1, 2. So the square of negative number is positive, so this become what? Sine pi x by 1, okay. And plus sine फॉर एन इक्वल टू 2, यहाँ पे 1 के लिए आपका क्या आएगा? पॉजिटिव हो गया, यहाँ पे 2 करेंगे 3 हो जाएगा, तो ये नेगेटिव आएगा. यस, ये नेगेटिव, ये पॉजिटिव, एंड देन नेगेटिव, एंड सो ऑन. and so on. Okay, so just simplify this. So this is equal to what?
और
This
तो
is
कॉस वाले में भी मतलब कि अल्टरनेटिव आएगा।
नहीं कॉस वाले में सेम आएगा, प्लस ही आएगा। यहाँ पे केवल और टर्म सर्वाइव करेगा ना, यहाँ पे और टर्म केवल सर्वाइव करेगा, इवन टर्म विल बी जीरो। इफ हियर n इक्वल टू 2 डाल दिया, सो दिस इज स्क्वायर ऑफ नेगेटिव नंबर इज पॉजिटिव, दैट इज 1, एंड 1 माइनस 1 विल बी जीरो। ओके, so for even case that will be 0, only what term is survive. So this equal to what? K by 4 and minus 2k by pi square, and write down cos pi x by 1 square. Okay, and plus cos 3 pi x by 3 square, and plus cos 5 pi x by 5 square, plus so on. Okay, and then plus k by pi. Okay, and यहाँ पे आपको मिलेगा sin pi x by 1 and minus sin 2 pi x by 2 and plus sin 3 pi x by 3 and minus so on. Okay, which is required Fourier series of the given function, which is require Fourier series of the given function. I hope you understood, student, how to solve this problem. Yes or no? Yes or no? हाँ, बहुत आसान है, ठीक है। सो इसको आपको सेम स्टार्टिंग का जो लेक्चर बैठा है उसको एक प्रॉब्लम समझ गया तो मतलब वो पूरा प्रॉब्लम कर लेगा Fourier सीरीज का। ओनली थिंग इज दैट योर इंटरवल इज डिफरेंट, देन योर फार्मूला विल बी स्लाइटली डिफरेंट, and otherwise all these things will be same. Get it? And should I give one problem based on this? One problem exercise आपको दे दूं, simple problem.
हाँ सर दीजिए।
Example, obtain the Fourier series of the function f of x. This is equal to what? F of x, and this is equal to pi x, when limit running from 0 to 1. Okay, limit running from 0 to 1, otherwise 0. X is running from 0 to here x is running from 0 to 1, and then x is running from 1 to 2. So this is simple exercise problem for you. Please do this problem at your home. Okay, each and everything will be same like a previous one. Okay, now the next topic is Fourier series in the interval minus L to L. Fourier series in the interval minus L to L. Okay, this is same case like even and odd function. So we will have even function. First one is what? We have even function. Okay, if f of x is even, function in the interval minus L to L. Okay, then we will have Fourier coefficient. Then we will have the Fourier coefficient a naught. A naught is equal to, your a naught is what? 1 upon 2L integration of limit minus minus L to L f of x dx, f of x dx. But what f is what? Even function. So this function can be written as what? F is even function. So 1 upon 2L. So this can be written as 2 times of integration of limit 0 to L f of x dx. Why this so? Since f is even. Okay, by property a definite integral. So this 2 and this 2 will cancel, and you will have only 1 upon L integration of limit 0 to L f of x dx. Okay, so this is formula for your a naught. Name this equation number 1. Okay, similarly you have bn, formula for an, then we'll come to bn. So then an will be what? Your an will be 1 upon L integration of limit minus L to L f of minus L to L f of x cos n pi x by L and dx. Okay, so what? Just apply the properties of definite integral. So this is the even function. F is even, cos is also even function. So this can be written as 2 times of L integration of limit 0 to L f of x cos n pi x by L and dx. Why this so? Since f is even. F is even. Okay, and this is equation number 2. Name this equation number 2. Okay, so this is formula for your an. 2 by L integration of limit 0 to L f of x cos n pi x by L dx. Okay, and also we'll have bn. Your bn is what? Bn is 1 upon L integration of limit minus L to L f of x and sine n pi x by L dx. Okay, see here, f is even function and sine is odd function. So even into odd, that is odd. So for odd case, by the properties of definite integral, this will integral is what? Integral is 0. For odd case, you will have integral 0. Okay, यहाँ पे write down since f is even. Okay, f is even and sine is already odd function. So even into odd, that is what? Odd. So for by properties of definite integral, bn will be 0. Okay, number 3. This is number 3. So for Fourier series in the interval, you will have a naught is 1 upon L limit running from 0 to L f of x dx, and an will be 2 by L limit running from 0 to L f of x cos n pi x by L dx, and bn will be 0. Okay, and substitute this value in equation number star and substitute और
सर ये bn वाला सर वापस बताइए ना सर, जियो कैसे आया?
gn वाला देखो, देखिए, you'll have the result. Okay, one result is there. And result properties a definite integral. Okay, so your result says that okay, dx वाला रहेगा ना. So this is 2 times of integration of limit 0 to a f of x dx. Okay, ये कभी रहेगा जब आपका f क्या रहेगा? f is even रहेगा. ठीक है, अगर इवन नहीं है तो क्या रहेगा? 0 रहेगा कभी जब f आपका ऑड रहेगा. ठीक है, एफ आपका ओड रहेगा तो ये आपका 0 होगा. ये देखो फंक्शन ओड हो गया ना. लिमिट देखो, लिमिट योर लिमिट इज माइनस एल टू एल, दैट इज व्हाट? माइनस ए टू ए. इस इंटरवल में ये आपका इंटीग्रल 0 होता है ओड केस के लिए. समझा आपको? यस.
तो ऑड रहेगा तो मतलब जीरो रहेगा।
हाँ ऑड रहेगा तो आपका जीरो रहेगा। ठीक, putting these values in following equation. Okay, in f of x equal to a naught plus some running from n equal to 1 to infinity an cos n pi x by l, and plus some running from n equal to 1 to infinity bn sin n pi x by l, इसमें आपको पुट कर देना है इन दिस इक्वेशन. ओके, this is required result. This equation we get required Fourier series. यहाँ पे आने के बाद ऑटोमेटिकली डार्क हो जाता है. We get required Fourier series. Okay, I hope you understood how to find Fourier series in the interval minus L to L. Okay. Similarly for odd case. Okay. Similarly for odd case we will have. Let us write down odd case also. For odd function. Odd function.
तो टाइम में फोन है.
हाँ होने दो, 5 मिनट है ना, इतना तो टॉपिक में लिख सकता हूँ. द प्रॉब्लम विल डू लेटर.
सर 3 मिनट है.
Yes, yes. We will finish within 3 minutes. Okay. Just write down. If f of x is odd function in the interval minus L to L, then what happen? Now listen, students. We will take 2 minutes, not more than 2 minutes. Okay. So odd function, if f of x is odd function in the interval minus L to L, then what? Then you will have a naught. You will have a naught. What is the a naught? A naught is equal to 1 upon 2L, and your limit is what? Minus L to L, f of x and dx. Okay, but thing is that f is odd function, so by properties of definite integral, this integral will be what? Zero, na? By properties of definite integral, this is 2 by L, and this integral is what? Zero. So you will have a naught is zero. Okay, a naught is zero. Now we will have an. The formula for an is 1 upon L, integration of limit minus L to L, f of x cos n pi x by L and dx. Okay, now see, here f is odd function. F is odd function, but cos is what? Cos is even function. So odd multiplied by even function, that is odd function. So by properties of definite integral, again an will be zero. Okay, you can write here since f is odd. F is odd. Okay, and name this equation number 1. Name this equation number 2, and also you will have bn, and bn is what? Bn is 1 upon L, integration of limit minus L to L, f of x sin n pi x by L
हाँ नहीं, बारिश का माहौल है.
dx. Yes, please mute your mic, those who are talking in between. Okay. So bn is what? Bn is equal to 1 upon L, integration of limit minus L to L, f of x sin n pi x L by L dx. Okay, but thing is what? 1 upon L. F is what? F is given to be odd function, but sin is also odd function. So odd multiplied by odd, that is even function. So this function will survive. So we'll have, for even case, by properties of definite integral, this integral can be written as what? But 2 times of integration of limit 0 to L, f of x sin n pi x by L and dx. Okay, so write in systematic way. So Bn will be what? 2 by L integration of limit 0 to L f of x sine n pi x by L dx. Okay, name this equation number. Name this equation number 3. Why this so? Because since you can say that f is odd, f is odd function. Okay, odd multiplied by odd is even function. That's why this function survive. Okay, now putting this value a naught, an and bn in equation number star. Putting this value in this equation. In this equation, which equation? This equation, f of x equal to what? A naught plus sum running from n equal to 1 to infinity an cos n pi x by L, okay, and plus sum running from n equal to 1 to infinity bn and sine n pi x by L, okay, in this and we get require Fourier series, required we get required Fourier series. क्या हो रहा है इधर? Fourier series. Okay, now based on this we'll do example later. Getting?